Ever feel like you need a translator just to keep up with the world of artificial intelligence? Well, you've definitely come to the right place. We are going to cut through all the noise and give you a simple, clear guide to how this stuff actually works. Let's dive in.
It's a total jungle of jargon out there, isn't it? Machine learning, deep learning, these terms get thrown around like confetti. But don't worry, we're about to bring some order to this chaos with a framework you can actually remember and use.
So, the first step to really getting a grip on this is to simplify. For our purposes, we can boil almost all the modern AI down to two main categories, two big flavors that power just about everything we see today. Let's meet them.
Honestly, it really just boils down to the kind of data they work with. Think of good old machine learning as being a genius with structured data. You know, stuff that fits perfectly into spreadsheets and tables. Its job is to find patterns in there and make predictions. Deep learning, on the other hand, is a more advanced kind of machine learning. It gets to tackle all the messy, unstructured stuff, like images, your voice, and text, by building systems that are actually inspired by the human brain.
Okay, so let's zoom in on machine learning for a minute. To make this stuff really stick, we're going to imagine its three main types as three distinct personalities, each with its own special way of learning about the world.
First up, we've got supervised learning. I like to call this one the teacher's pet, and for good reason. This approach learns best when it's given crystal clear examples with all the right answers already filled in.
The magic words here are labeled data. So imagine feeding a computer thousands and thousands of emails, where every single one is already marked spam or not spam. The algorithm just pores over these examples until it starts to figure out the patterns for itself, and boom, it becomes an expert at spotting spam in any new email it ever sees.
And you see this everywhere. Seriously. Every time Netflix nails a recommendation for a movie it thinks you'll love, or your bank figures out a credit score, that's supervised learning doing its thing, making smart predictions based on all that past labeled data.
All right, our next personality is unsupervised learning. Let's call this one the detective. Now, unlike our teacher's pet, this one gets zero hints. It's basically thrown into a giant mess of data and told, go figure it out. It has to find the hidden clues all by itself.
So with this one, there are no right answers to learn from. The algorithm just sifts through this massive data set and starts clustering things that look alike. It might not know what these groups are, like it can't say, oh, these are your high-spending customers, but it becomes an absolute master at seeing that different groups exist based on their hidden similarities.
And this is just incredibly powerful for businesses. They can use it to automatically sort millions of customers into unique groups based on how they shop, or find these really subtle patterns in data that a person might, well, that we might never ever spot. It's a real discovery engine.
And that brings us to our final machine learning personality, the explorer, also known as reinforcement learning. Now, this one is completely different. It doesn't learn from a big pile of data at all. Nope. It learns by getting out there, exploring an environment, and actually doing things.
You know, the best way to think about it is like training a puppy. You don't give the puppy a textbook on how to behave, right? It tries stuff. And when he does something good, you give it a treat. The algorithm does the exact same thing, trying millions of actions in a virtual world to slowly but surely discover which moves lead to the biggest reward.
This is precisely how DeepMind's AlphaGo taught itself to become the best Go player on the planet, just through millions of games of pure trial and error. The same approach is now being used to solve other huge complex problems, like figuring out how to make giant data centers way more energy efficient.
So, that's the foundation of machine learning. Now let's talk about its most powerful and maybe most famous branch, deep learning. This is the engine that's running behind some of the most mind-blowing AI applications that we see today.
The secret sauce, the real magic here, is something called a neural network. It's an algorithm that's literally inspired by the web of neurons in our own brains. By creating these complex layers of interconnected digital neurons, these systems can learn to recognize incredibly complex patterns in things like images, sound, and language.
Now, to keep it simple, we can really just focus on two main types. First, you've got convolutional neural networks, or CNNs. Just think of these as AI's eyes. They are the undisputed masters of understanding pictures. Then, you have recurrent neural networks, or RNNs. And you can think of these as AI's ears, specializing in things that happen in a sequence, like spoken words or written sentences.
And believe it or not, you use these superpowers every single day. The Face ID on your phone? That's a CNN seeing you. When you ask Alexa or Siri for the weather, an RNN is processing your voice.
Deep learning is truly the magic happening behind the curtain of so much of our modern tech.
Okay, so these concepts are pretty fascinating, right? But what's the real-world impact? Why does understanding any of this actually matter? Well, as it turns out, the value here is astronomical.
Let's just go back to our teacher's pet, supervised learning. That recommendation engine that Netflix has, it's a perfect example. Just by predicting what you'll probably want to watch next, it's estimated to be worth around $1 billion every single year. That's the power of applying just one of these tools in the right way.
And this really brings us to the single most important takeaway from all of this. The true promise of AI isn't about replacing people. It's about augmenting us. It's about giving us superpowers. Giving doctors better tools to diagnose diseases, helping scientists discover new medicines faster, and even letting artists create things in ways we never thought possible.
So now you've got the toolkit. You've met machine learning's 3 personalities, and you understand deep learning's brain-like superpowers. The real question is, now that you know how it all works, where do you think these tools are going to make the biggest difference next? What incredible problems are we going to solve?